Hi there, my name is Emilis Haralabidis, and in this video, which is actually a part of a bigger series of videos focused on AP Precalculus, we will start going over part by part the entire syllabus of AP Precalculus. So let's begin with Unit 1, which is titled as Polynomial and Rational Functions. And what you need to know is that this unit basically contains 30 to 40% of the entire AP exam weighting. We will begin with some prerequisite knowledge on functions. Actually, Unit 1 is entirely based on functions, but before we jump into it, we certainly need this prerequisite knowledge. We will begin by some definitions. At first, we have the definition of an ordered pair. So, an ordered pair is actually any formation x, y. That's called ordered pair. So, for example, 3, -1, 2, root of 2, 0, 0, and so on are all ordered pairs. Now, to a relation. A relation is a set of ordered pairs. We just saw what an ordered pair is. Now, a set is basically a collection of items. In our case, these items will be the ordered pairs. So if we group together some ordered pairs, then that's how we create a relation. Usually, we denote relations by capital letters, and since they are sets, we should put them in these special brackets. So, for example, 1, 3, 2, 0, 1, 6, this will be a relation. Another relation, let's call it B this time, would be this one. 1, 1, -1, 6, 6, 5, 3, 2, and so on. So far, ordered pair, any formation x, y, a relation, a set of ordered pairs. Input and output values in a relation in the third definition for today. Input and output values. Given a relation, assuming that we have this relation, 3, 4, 5, 10, actually, not just in a relation, given an ordered pair, let's discuss this one, 1, 2, the first number we see in front of us is called input value, while the second one is called output value. Again, in 3, this is the input, and that would be the output. Here, this is the input, and that would be the output. In general, in a random ordered pair x, y, x is the input and y is the output value. Domain and range of a relation. Given a relation 1, 2, let's use this example, 3, 4, 5, 6, and 1, 10, if we recreate a set that includes all input values together, in our case, it would be 1, 3, 5, and we don't need to repeat 1, then this is how we form the domain. So the domain is just the set that contains all input values. Similarly, if I now collect all the output values, again, it's a set, so I need to put that in that special pair of brackets, 2, 4, 6, and 10, then this is how we form the range. So that would be the range. Mapping diagram of a relation. Remember that so far we have seen the following definitions. We began by what an ordered pair is. Then we said what would happen if we collect lots of ordered pairs. Then we defined the input value and the output value in a single ordered pair. Then we said that if we collect in a relation which consists of many ordered pairs, if we collect all the outputs the inputs together, the input values together, then this is how we form the domain. While if we collect all the output values together, that's how we form the range of that relation. Now, based on this, we will be discussing how to draw the mapping diagram of a relation. The mapping diagram is just a visualization. It's a visualization of how input and output values are related. To draw it, I draw two clouds. On the left one, we will put all the input values, and on the right one, we will put all the output values, and I will start connecting the input values with their corresponding output values. So, for example, assuming that I have this relation 1, 2, 3, 4, 5, 6, and 1, 2. At the left, I said that I will be putting all inputs without double writing them. So it's going to be 1, 3, and 5. Then I will use all the output values, again, without double writing them. 2, 4, and 6. 2, 4, and 6. And now, based on the suggested connections from the ordered pairs, I will connect them with arrows. So from 1, we go to 2. From 3, we go to 4. From 5, we go to 6. It was 1 to 2. So let's make that 20. Let's put another 20 here. So from 1, we go as well to 20. And this is the mapping diagram for this random relation. Now, we can classify relations based on their mapping diagrams. At first, we have a one-to-one relation. A one-to-one relation would look like that. Let's draw it like that. 5, 2, and 10. The characteristic in this type of relation is that every input value is connected to one specific output value. Another definition about that would be, an equivalent one would be that different input values relate to different output ones. Many to one. Many to one. You should remember that when it comes to imagination in naming things, mathematicians do not have that much, let's say it like that. So many to one, it's basically what you would think of it. Many input to the same one output. Two or more input values related to one output. One to many. Similarly, this goes like that. One input to more than one outputs. One input value related to more than one output values. Onto. Onto is I'm going to give you one example, is when for every output value, there is at least one input value related to it. So what I drew is on top. An example of a relation not being on top would be, let me draw it somewhere here, could be this one. You see that for this output value, there is no input value relating to it. Now, let's seal this first video of this series about the AP Precalculus with some exercises. For each of the following exercises, find the domain, the range, and represent its relation algebraically. We will skip that. We will do the first one only to find the domain. The domain would have been, like we said before, the set of all input values. It's a set, so we need to group it into this special pair of brackets. And without double writing, we should include all input values. This is a domain. And with regards to the range, similarly, we will just collect all output values, 10 and 12. Now, if we wanted to classify that, we would say that it's certainly not one-to-one. It is because we can see here that we have this thing going on. It is definitely a many-to-one. It's not one-to-many, and it's not onto because this number here, number 6, is not related anywhere. And that would be all. If you found this video helpful enough, please do not forget to subscribe and hit the bell so that you don't miss the next lesson. As always, thank you for watching. I'll see you in the next video.